definition of a rectangle. So definition of a rectangle, real simple. It's a quadrilateral with 4 right angles. Okay. So it's just have to have 1, 2, 3, 4. Now, question, is a rectangle a parallelogram?
Yeah.
Yes. So do all the properties of parallelograms apply? Yes.
Yeah.
So we know opposite sides have to be parallel, right? We know opposite sides have to be congruent. We know opposite angles obviously are congruent. Consecutive angles are congruent. And there's one more, diagonals bisect each other. Okay. So all of those properties are going to apply. We have an additional one that applies just to rectangles. So not only are the diagonals going to bisect each other, what else do we know? What do we think about the diagonals? They have to be congruent. Okay, so that means AC has to be congruent to BD. Okay, so let's try to prove that theorem. Okay, so we're starting out with a rectangle ABCD. And we want to prove AC is congruent to BD. So let's just go ahead and draw from A to C, B to D. Okay, any ideas? So we have a rectangle. So we can use the definition of rectangle, and we can use any other previous theorems or definitions. Well, we want to prove, yeah, I mean, you could say the lines are parallel. We could say, so anything that applies to a parallelogram will also apply to a rectangle. But ideas, Eli, what do you think?
You could do AD is congruent to BC.
We could do AD congruent to BC. How will that help us?
Because then you could do AC is congruent to AC, BD is congruent to BD, and then 2 right triangles there.
Well, we can't do, yes. Okay, so here's, if we can get this triangle, ADC, oops. If we can get this triangle congruent to this triangle, right? Do you see it, how they're overlapping? So if we can get this triangle congruent to this triangle, then these 2 sides will be congruent by CPCTC. Make sense? Okay, so Eli started out with AD congruent to BC. And that is, in a parallelogram, that implies opposite sides are congruent. Okay. What else do we have? DC is congruent to DC. They overlap. They both share that same side. So DC congruent to DC. Now, you had said hypotenuse leg, but we're really technically trying to get the hypotenuse of each of these triangles congruent. So we can't use that, but what else can we say? Okay, we can get to D is congruent to C. But first of all, we have to say that they are what kind of angles? Right angles. So let's put that in. So angle, and I'm going to use 3 letters. So I'm going to use angle ADC congruent to BCD. Or sorry, I said, I even said it. We have to say they're right angles first. Sorry. That is definition of a rectangle. Okay, 2 more steps. Now that they're right angles, now we can say they're congruent because all right angles are congruent. Okay, almost done. So now we'll say they're congruent.
So then you can do side angle side.
Now we could do side angle side because we have these 2 angles. So everyone see that? So the one here, like the pink side angle side, the one I traced in blue, side angle side. So we just have to make sure the order of the letters matches. So I think we can do that same order, right? ADC and triangle. BCD, same thing, right? Okay, now we have the 2 triangles congruent. We can go with CPCTC to prove, oops, AC congruent to BD. All right. Good. Any questions on that? Okay, so let's do a couple of applications. We have a quadrilateral ABCD is a rectangle. So if AC equals 30 minus X and BD equals 40 minus X, what's the value of X? Well, what are we going to do? AC is this.
30 minus.
That's 30 minus X. And BD, yeah, what did we just prove? We just proved that they have to be equal to each other. So we have 4X minus 60 equals 30 minus X. What do you think? 5X equals 90. 90 divided by 5. 18. Okay. All right, now, next one. NR is 2X plus 10. So this whole thing is 2X plus 10.
So we have to do like 2 times 2x minus 30 equals 2x plus 10.
Yeah, and how do we know that these are the same measure?
The diagonal bisect.
Diagonals bisect each other, and now that we know that the diagonals are also congruent, what ends up happening are all of these 4 segments are going to be congruent to each other. Oh, I marked the wrong one. It doesn't matter. Does that make sense? Because they're congruent and they bisect each other. So all of these segments are the same. Okay, so yes, we'll do 2 times 2x minus 30 equals 2x plus 10. That's not the only way to do it. We could also take 2x plus 10 and divide that by 2 and make that equal to the other one. Let's see, what do we get?
X equals 35.
Uh-oh.
Well, when you plug in.
Oh, I see what you're saying. Okay,
Oh,
so
fine,
what?
yeah.
Yeah, so we're gonna find x first.
Wrong.
That's 40.
I got fine.
So 2x equals 70. So x equals 35. And MP would have to be 2 times 35 minus 30, because it's the same as NP. And good, we get 40. Okay. How are rectangles so far? Good. That's why I said this will be pretty straightforward. Okay, we have another rectangle. We want to find the value of x and y. What do you think, Ryan?
We're saying that 4x plus 9x plus 12 equals 90.
Okay, so these, we have 4x plus 9x plus 12 has to add up to 90. Yeah.
I also did that since they're y squared minus 1 and 4y plus 4 are alternate.
Those are alternate interior angles, so yes, we can also make these two equal to each other. So we'll have y squared minus 1. Okay. Let's solve. And what happens with x?
X equals 6.
6.
X equals 6 because we get 13x equals 78. Okay, good. And what about y? So we have one like this on the quiz where we have to move everything to one side. So y squared minus 4y.
Y equals 5 and negative 1.
Okay, so y minus 5 and y plus 1. Good. Now, can y be equal to negative 1? And can y be equal to
Yeah.
5?
No.
Yeah, negative 1.
Well, if I plug in negative 1, I'll get negative 4 plus 4. That's 0.
Yeah, but look, it equals the. Oh, wait, you can't take just
Can I have an angle that's 0 degrees?
Never mind.
No, so we're going to just cross off the negative 1, and then we'll just circle the y equals 5. Hi. All right. Oh, here, Oren.
Yeah.
Here, grab one of these. That one over there is broken. All right, welcome. It's all good. Okay. All right, let's take a look at next example. Now we just have one more page. So measure of angle 1 is 35 degrees. We want to find all these other angles. Okay, so what do you think?
2 is 55.
Angle 2. Okay, so we know it's a rectangle, so all the angles are 90. So yes, this has to be
6 is 35.
okay. And angle 6 is 35. Yeah, that's good. We know alternate interior angles. And what else? What else do we know? Which one? Angle 3 is 55? How do we know that?
Oh.
It's right, but why? Okay, remember what I said about all the diagonals? These are all congruent. That makes every single triangle in here ends up being an isosceles triangle. What do we know about the isosceles triangle? We know the two base angles have to be congruent. So if you kind of just focus on this triangle, these two sides are congruent. So 2 has to be congruent to angle 3. Do we see that?
And then 5 has to be 35.
So angle 3 is 55. And then what else? 5 is 35.
And so then 4 has to be
70.
Yeah, so now inside the triangle, we know it has to add up to 180. So these add up to 110.
7 is 110.
7 is 110.
7 is
8
110.
is 55.
8 is
This is 110. We said this was 70. 8 is 55. Good. So in a rectangle, if all you know is one angle, we can figure out all the other angles based on the fact that these are all isosceles triangles. Okay? Sophia? Okay? All right. All right, last thing. So now we're just going to look at the converse. So if the diagonals are congruent, then we have a rectangle. Okay? So this is just how can we prove, right? If the diagonals are congruent, then it has to be a rectangle. Okay. So let's graph it. All right, -4, -1. Here's D. Okay. Now there's actually more than one way that we can prove that it's a rectangle. One, we can show what? The slope. We can look at the slopes are opposite reciprocals. That would make, so we could do slope 4 times, or we can do the distance formula twice. How would we do the distance formula? We're going to check the diagonal. So since we haven't done the distance formula in a while, I know. Let's do a little refresher because this is one of those formulas that will not go away. You're going to have it again next year. So what is the formula? X2 minus X1 squared 2 minus Y1 squared. Now, if I'm just checking the diagonals, I want from H to F and from D to G. And actually, I don't need the segment line above. Okay, so let's focus on H and F. Now, it doesn't matter which one I make, X1 and X2, right? Or Y1 and Y2. What do you think? Square root. We remember this, right? So 2 minus -2, which will make that 2 plus 2 squared. And then what? 2 minus -5. What do we get? 16 plus 49. 65? 55? 65? 65. All right. So if DG ends up being the same length, we have our rectangle. And if it's anything different, it's not going to be a rectangle. So now let's look at D and G. I'll let you guys go ahead and try that next one. You already doing it here? No, you're just looking at it? Do we get the same thing or something different? You got the same thing, Taylor? Yeah. You got the same thing? All right, so let's see. 4 minus -4. So that would be 4 plus 4 squared. And -2 minus -1. It looks like it's going to be the same thing, right? We have 8 squared plus 1. All right, so D, F, G, H is a rectangle.